Okay, so a lorry of mass 4 tons travels at a constant speed in a straight horizontal road with its engine producing a pulling or driving force of 2,000 newtons. What is the resistance to motion? Okay, so we're always going to draw sort of like a sketch, okay, a force diagram sketch. It's useful. It doesn't ask for a force diagram sketch, but it will help us to see exactly what is going on here. So we've got this driving force, so we'll assume now it's going to the right. It's always best to assume that, so accelerating that way. And we need to work out what the resistance is there to the motion. So we need to work out what the resistance is. Okay, so we can call the resistance anything we want there. We can call it S if we want. We can call it anything. And of course we put the weight in. So the weight then would be 4 tons. So that's 4,000 kilograms. Yeah. So that would be 4,000 times G. 4,000 times the acceleration caused by gravity, and then we've got a reaction then because the road is holding that lorry in place. Now the key to this then is that it says constant speed. Okay, so at constant speed the speed doesn't change, so acceleration is 0. So in other words, the resultant force is equal to 0. So when you apply Newton's second law, yeah, which is what we were doing here, the resultant force equals mass times acceleration. Okay, and because the acceleration is 0, that's where we've got 0 here, mass times acceleration. So the resultant force then would be 2,000, take away S is 0, and that means then S would actually equal 2,000 newtons. They balance. The forces have to balance if we've got constant speed. Okay, so in B then, it says if the pulling force is increased to 6,000 for the lorry, with the resistance remaining the same, then the lorry will accelerate. What is the acceleration? So basically the diagram above now, I won't draw it out completely again, but I'll just adapt it. And the fact is now that driving force has changed to 6,000, but the resistance is now only, it's the same, isn't it? So the resistance is still 2,000. So if I apply now Newton's second law, remember resultant force, I'll just put RF, okay? Resultant force is mass times acceleration. So the resultant force will be the 6,000, the driving force, take away the resistance, which is 2,000, and that will be the equals then to the mass of this lorry, which is 4,000 kilograms times A. So if we work that out, well, this becomes 4,000 times A, so that means A has got to be 1, yeah? So it's accelerating at 1 meters per second squared. With C then, if the lorry is moving in a horizontal direction, find the normal reaction between the lorry and the ground. So going back to this diagram here, remember there's no movement vertically. So vertically, forces are balanced, yeah? Forces are balanced, or equilibrium is the word we tend to use. So that means then R has got to actually equal to 4,000 G. It's equal to the weight. So they balance out there. So we can actually work out what that is in newtons by timesing 4,000 by the value of G. And we get 39,200 newtons.